Okay, I gotta make this video quick. I've got some kids out in a cage in my backyard and they're starting to get hungry, so I gotta go out and feed them. This one is about how we get mostly two forms of energy transfer through space. We have electromagnetic energy forms in which go out three-dimensionally, and then we have photon energy transfers that go out in small unit packets. And getting both those forms to propagate through space is a really difficult thing, and everyone in the 1800s got in arguments over whether light was a wave or a particle. An atomic bomb explodes. We're also dealing with the explosion going so fast that it is propagating at the speed of sound. So here we're getting the maximum speed of the median. So here it's the maximum speed of the median, and what's happening is there becomes a point where it spreads out and then it doesn't spread out anymore. So the median itself, you have a velocity. You get to the point where there's a velocity where, like a sandblaster, the air going this direction actually sucks back, pulls air towards it. You can see that if you were to take a piece of paper and an air compressor and blow air across it, the paper would actually get lifted up to the air. Airplane wings work under that same principle. So what's happening is it creates a column going straight up, or in the case of a photon, you're putting a very small package, and we're not vibrating the media anymore. What's happening is this media has packed together and is punching through the rest of the media at the speed of light. And as it punches through, it creates an expansion, and then it creates a vacuum. And what happens in a vacuum is when things come together, if they're moving, that movement increases speed. And here we have the spin, or basically a hurricane type vortex moving in a straight line. Okay, 3D quantum dot. Three phases or three types of ways of looking at, and that is a solid where they have where you put them in layers and they fit together in layers. That of liquid, in which they have more energy in that, and the vibrational energy keeps them from fitting together, and this allows them to move pretty much like liquid. And then there's a gaseous phase, which says that they have so much energy that the pressure pushing them together is being counteracted by the energy inside and them bouncing around. So it's very easy to look at it as a gas, liquid, or solid phase, even though that's not really what it is. The first two is real easy to see how the waves would create three-dimensional propagating waves. The problem is with photons, you can't get a packet wave through this type of media, or at least nothing that I've been able to figure out. With the gas, I have been able to figure it out, and I saw it when I saw a nuclear bomb test. So going to the next page, we're putting Bernoulli's principle together along with laminar flow. So what's happening is when you see a nuclear bomb go off, it expands circularly to a point, and that point is where the velocity of the atoms exceeds the pressure pointing outwards. That means that this is where Bernoulli's principle takes effect, so that the velocity is actually putting pressure up against the moving particles, and the pressure going out equals the Bernoulli pressure loss due to velocity of the actual objects. And it would be a laminar flow, which means you would have a hyperbolic curve up here, and it would also create, or I think it would also create, the mushroom cloud in front of it, which means we have one vortex wave going this direction, and seeing as this is a short burst, it's not a continuous explosion. It's just a short burst, so it would be a small packet going forward. So that means you would have this collapse of, I guess, collapse of dots going in here. And what happens when they collapse, any spin that they have going this direction or that direction would be enhanced, and it would be enhanced outwards, and it would be taken along with it as it went. So therefore we have either a right hand, or I should say clockwise or counterclockwise motion going around, a spin. And it's not really a complete circular spin, as it is just a shift or a motion of all the objects within it are being turned. It's not just so much as it's a wave pattern, but it's a magnetical wave pattern where it's being shifted and there's waves on it, waves in the motion also. So we have, if this packet wave is moving at the speed of c, and the shifting is moving at the speed of c, then what's happening is we have vibration in the packet also. So that if we have something hitting it here, it's not necessarily coming out on this side. We'd need to see some computer-generated computer-generated material on this. So this is just a basic idea of what I'm going over, and I'll have to do the rest of it on another video. And again, we have a packet. If something hits it hard, it's pushed off, it comes around, and then we have the vortex coming in, and we have a circular pattern going around the vortex, this making either a right-hand vortex or a left-hand vortex behind it. So the things we got to remember on this is that in the vortex models I made, that if the vortex itself is pulled on, then it pulls on the packet also, and it can actually spin the packet. So this isn't possible unless there is space inside here. These are in vibration, and each one of these are in vibration, and this vibrational speed here is faster than the actual wave speed. So the wave speed is equaling an accumulative velocity of that dot going up to a wave crest and then coming all the way back. So it is an accumulative average of distances traveled, and that's how fast this wave can follow. It's how fast rotational waves can follow, and it's how fast any other propagating wave can move through this. And it's time to move on. Let these guys out. Release the Kraken! Yeah! Come on, yahoos.